Welcome back to BSpice. In this session, under OT cybersecurity, we'll continue defense in-depth architecture capabilities. Section 4, we'll talk about layer 4, hardware security. So let's get started. Yes, if you're a first-time viewer, layer 1 we had already covered, which focus more on security management, and layer 2 we talked on physical security, and layer 3 network security. It's all we had already covered, and it's available in BSpice. If you're interested, you can watch and get benefited. Then layer 4 is more on hardware security, and of course layer 5 will be covering in the next session, which talks about software aspects. Now let's get started with the hardware security. Hardware security protection mechanism provide the foundation for supporting security and trust for the devices within an environment. So basically, this hardware security protection provides a foundation for supporting the security and trust for the devices. Once the device trust is established, the state must be maintained and tracked in accordance with the system model and policies. To support these capabilities, some vendors provide embedded technology such as trusted platform module TPM or hardware implementation for advanced encryption standard AEC and secure hash algorithm SHA. Okay, you may be wondering what is all about this trusted platform module. Yes, trusted platform module TPM is a specialized software chip embedded in computers and other devices to enhance the security by securely storing cryptographic keys, passwords, and other sensitive data. So this TPM provides a hardware-based root of trust, meaning it ensures that the system starts in a secure and verified state. So it is used to, secure the boot processes. Boot process in the sense it verifies that operating system hasn't been tampered with. And also it encrypts drives, works with tools like BitLocker to protect the data at rest, and also it stores credentials, keeps encryption keys, digital certs, and passwords safe from software based attacks. And also it enables platform integrity, meaning it measures record system states to detect unauthorized changes. That's what TPM does. So when we talk about the key features of the TPM is isolated from the main CPU memory and making it harder to compromise. It also have a cryptographic operations, and also it has a unique identity. Each TPM has a unique endorsement key burnt into it during the manufacturing. So it secures the storage. It keeps keys and credentials in non-volatile memory. Okay. So you may be asking where this TPM is used. Yes, its TPM is used in BitLocker drive encryption, that is used for Windows, and also it uses used in secure boot and measured boot aspects, credential guard and Windows Hello, and also the digital rights management and virtual smart cards. All these about the TPM. Right, then we talk about the hardware implementation for advanced encryption standard, AES. Yes, AES, advanced encryption standard, is widely used symmetric encryption algorithm that secures data by converting into an unreadable ciphertext using a secret key. It's recognized globally for its speed, strength, and reliability in protecting the sensitive information. When we talk about the key features of the AES, yes, AES uses the same key for both encryption and decryption, making it efficient for secure data exchange. It also, block cipher. It encrypts data in fixed blocks, fixed size blocks of 128 bits. AES supports a three key lengths. AES 128, 10 rounds of encryption, AES 192, 12 rounds of encryption, and AES 256, 14 rounds of encryption. How this guy works? Basically, this AES transforms plain text into ciphertext through a series of operations. So that's all about the AES, friends. Okay. So you may be asking where this AES is used. Yes, it's used in secure web communication. You would have known, right? This HTTPS. Yeah, that's it's used. And VPNs and encrypted messaging apps. All these, and of course, wireless security protocols, WPA2, WPA3. It's all, the application of AES. Then we have a hash, secure hash algorithm, right? SHA. So again, this is a family of cryptographic hash function designed to ensure data integrity by producing a fixed size hash value from input data. These hash values are unique digital fingerprints used in security protocol, digital signature, and data verification. What exactly the SHA, secure hash algorithm does? SHA takes an input like file or password or message and generate a unique fixed length string called a hash. Even a tiny change in the input produces a completely different hash, making it ideal for detecting tampering. Okay. It's basically a one-way function. You can't reverse a hash to get the original input. It is deterministic, meaning the same input always produces the same hash. And collision resistant. It's extremely difficult to find two different inputs with the same hash. So that's all about them hash. Then you may be wondering where this is used. Yes, it is very much used in digital signature, password hashing, blockchain and cryptocurrencies, and file integrity check, and other certificates like TLS, SSL certificates. So to sum up, SHA is a cornerstone of modern cybersecurity, helping verify authenticity and protect data from tampering. That's all about this SHA, friends. I hope I given some inputs on TPM, AES, and SHA, SHA. Let's continue. Overall hardware security capabilities enhance the endpoints to provide specific function and security handling, including monitoring and analysis. So, what is about the monitoring and analysis? Monitoring and analysis in hardware security involves continuously observing hardware system to detect vulnerabilities, performance issues, and potential cyber threats, ensuring the integrity and reliability of critical infrastructure. So, this process is essential for preventing breaches and maintaining operational continuity. So, monitoring and analysis in hardware focus on the tracking of the health, performance, and behavior of physical devices such as routers, servers, switches, embedded system, all these actually. What are the key aspects on this monitoring and analysis? Yes, it performs real-time performance tracking, ensures devices operate with safe parameters, and also it involves in threat detection, identifies anomalies that may signal malware, unauthorized access and hardware tampering, and event logging and auditing. Yes, it records system activities for forensic analysis and complaints. And predictive analytics, yes, uses historical data to anticipate failures or security breaches. So that's about the monitoring and analysis. Then we have a secure configuration and management. What is secure configuration and management? Secure configuration and management refers to the process of setting up and maintaining IT system, applications, and devices in a way that minimizes vulnerabilities and ensures compliance with security standards. So it's basically a foundational practice in cybersecurity that helps prevent misconfiguration, one of the leading causes of data breaches. I hope you agree with this. So secure configuration involves, applying security best practices during the setup of hardware, software, and network components. This include, disabling the unnecessary services and ports, changing default passwords and settings, applying least privilege access controls, and enforcing encryption and secure protocols, and regularly updating and patching the system. So that's about the secure configuration and management. Then we have a endpoint hardening. So what is this endpoint hardening? Endpoint hardening is a process of securing devices like laptops, smartphones, servers by minimizing their attack surface and enforcing strict security controls. It's a critical defense strategy to prevent unauthorized access, malware infection, and data breaches. So endpoint hardening involves configuration devices to reduce vulnerabilities and resist exploitation. So that includes disabling unnecessary services and ports, removing the default accounts and credentials, applying the principle of least privilege, and enforcing the strong authentication and encryption, and regularly updating the software and firmware. So that's about the endpoint hardening. Then we have a integrity protection. So what is this integrity protection? Integrity protection in cybersecurity refers to the data remains accurate, consistent, and unaltered throughout its life cycle, whether it's a rest or in transit or during processing. It safeguards against unauthorized modification, corruption, or tampering, which is vital for maintaining trust and operational reliability. So integrity protection is one of the three pillars of CIA triad. You would have known, right? CIA, confidentiality, integrity, and availability, CIA. So while confidentiality protects the data from unauthorized access and availability ensures the systems are accessible when needed, integrity guarantees that data is trustworthy and unchanged. So all this about the integrity protection. Yes, integrity, involves in accuracy, meaning data must reflect the correct values and states, and it supports consistency. Information should remain uniform across system and time, and also it helps authenticity, ensures data originate from a verified source, and of course the tamper detection, it identifies unauthorized changes or corruption. That's about the integrity detection protection. Then we have access control. So what is this access control? Access control is a cybersecurity strategy again that regulates who and what can view, use, or modify the resources in a system, ensuring that only authorized individuals or processes can access sensitive data. So it's again a foundational element of data protection and risk management. So access control defines and enforces policies that determine who can access which resources, under what condition, and to what extent. It involves three key steps. Basically, this identification, recognizing a user or a system, then authentication, verifying identity, password or biometrics, right? And finally, the authorization, it granting permission based on the roles or attributes. So this helps prevent unauthorized access, data breaches, and insider threats. That's about the access control. Then we have a device identity. What is device identity? It refers to the unique cryptographically verifiable representation of a physical or a virtual device within a digital ecosystem. It enables system to authenticate and authorize devices just like users, ensuring secure access and communication across networks. So device identity is a foundational concept in cybersecurity that allows organizations to treat devices as trusted entities. Each device is assigned a unique identity, often rooted in hardware-based trust mechanism. Such as, we talked about this trusted platform model, TPM, right? Yes, all these actually. So that's about the device identity. Then we go into the very important topic, root of trust. What is this root of trust? A root of trust is a foundational security concept that refers to a set of hardware, firmware, or software that are inherently trusted to perform critical security functions. These components serve as a basis for establishing a trust in a computing system. A root of trust is a starting point for a secure system, ensuring that all subsequent operations like booting, authentication, encryption are based or verified and trusted components. It's often embedded in hardware to prevent tampering and to provide a secure anchor for the entire security architecture. According to Trusted Computing Group, this ROT, root of trust, helps verify that the device or a system is communicating only with trustworthy elements. As you know, friends, this National Institute of Standards and Technology, NIST, defines root of trust as a highly reliable component that must be secure by design and are often implemented in hardware to resist malware. So that's about the root of trust. Then we have a physical security. So physical security protects an organization, people's property data from physical threats such as theft, vandalism, unauthorized access, and environmental hazard. It's a critical layer of defense that complements security efforts. Physical security involves safeguarding the physical assets like buildings, server devices from intrusions or damage. It ensures that only authorized individual can access sensitive areas and equipment that helps to prevent breaches and that could compromise the digital system. According to IBM and Cybersecurity Council, physical security is often overlooked, yet it plays a vital role in preventing cyber attacks that originate from physical access points. That's about the hardware security, friends. So, thanks a lot for your support. Yes, coming up next, defense in depth architecture capabilities and session 5, the last video in this on this subject, which talks about the layer about software layer. Okay, layer 5, which talks about the software. Thanks for watching. Take care. Bye bye. See you soon in the next video.